All right, it's our last lesson of the year, and we'll be solving rational equations today, so equations with fractions. So when you're solving rational equations, you've got two options. Your first option is to multiply both sides of the equation by the lowest common denominator, the LCD. That will help you just get rid of your fractions altogether, and a lot of people like doing that. And then you can solve the resulting equation. Or two, if it's set up as a ratio is equivalent to another ratio, you can just solve it by cross multiplying. I recommend solving it by cross multiplying if it is set up in that manner, and that's the easiest way to do it. So let's look at some problems. So we're going to solve 3 over 8 plus 4 over x equals 14 over 2x. So the first thing I want to deal with is what is my common denominator? So I'm looking for something that 8x and 2x all go into. So I like to look at it numbers and then variables. So for my number parts, 8, 1, and 2, they all go into 8, so I'd probably pick 8. And then for my variable parts, x, I just need an x. So 8x is my lowest common denominator. So what I'm going to try to do, unless you actually want to work with fractions, in which case you could transform all of those into fractions with common denominators of 8x, but I'm going to show you the technique that's usually faster for people, which is multiplying it out. You're going to multiply 8x by both sides. So 3/8 plus 4 over x equals 14 over 2x. We're going to multiply that by 8x as well. Okay, so the trick in multiplying here is that you really deal with that denominator first and cross-canceling when you can. So if I'm doing 8x over times 3/8, okay, so I really want to just be able to cross out those 8s because you know they'd be, so that's just going to be 3x. Okay, and if I did 8x times 4 over x, this time I would cancel out my x's and I would just have plus 32. And here, if I had 14 over 2x times 8x, well, this times 2x cancels out and that becomes a 4. So 14 times 4 is 56. Okay, once you've done that, multiply both sides by 8x, it looks so much more simple. We've just got 3x plus 32 equals 56. That's just a normal linear equation that all of you are more than capable of solving. We get 3x equals 24, divide both sides by 3, and we get x equals 8. Okay, I want you to get in the habit of checking your solutions because it's going to make it so there's a lot fewer mistakes. So I want to know if 3 over 8 plus 4 over x, which I think is 8, really equals 14 over 2 times x, which 2 times 8 is going to be 16. So 3/8 plus 4/8, that's 7/8. 7/8 does equal 14/16, so that checked out for me. All right, let's try another one. Same strategy and see if we can practice this. So 6 over x squared equals 5 over x minus 1. So again, I'm going to look for a common denominator to multiply everything by first. So I have my x squared x, and that's like 1 over 1. So something that all of those go into is x squared. So I'd call my lowest common denominator x squared. So what I'm going to try to do is multiply everything by x squared. So x squared times 6 over x squared equals 5 over x minus 1. That entire expression times x squared. Okay, so again, don't forget about your cross canceling. You can do it in your head or just write it out if you need to. X squared times 6 over x squared, that's just 6. The x squareds will cancel out. If I do x squared times 5 over x, well, and x will cancel out of the numerator and denominator, and I will just have 5x. X squared times a minus 1, no denominator to cancel out, so that's just going to be minus x squared. All right, when you look at this, it's not just a simple linear equation, it's a quadratic equation. So I'm going to want to set one side to equal 0. I always like to have a positive x squared, so I'm going to add x squared to both sides, and I'm going to subtract 5x from both sides. And so I'm going to have x squared minus 5x plus 6 equals 0. All right, and so I'll solve this by factoring because I'm getting pretty good at that. I think x minus 3 times x minus 2 would equal x squared minus 5x plus 6. And so therefore I think x equals 3 or x equals 2. I want to check just in case there's an extraneous solution or something that's just funky here. So let me see how much room I have. But 6 over 3, we'll try 3 first. 3 squared. So 6 over 9 equals 5 over 3 minus 1. I want to check if that's true. So 2/3, does that equal 5/3 minus 1? That's 1 2/3 minus 1, which is 2/3. So yes, 3 checks out. Okay, let's check 2. So this time I think 6 over 2 squared, which is 4. Does that really equal 5 over 2 minus 1? So that's going to be 3 halves. 5 halves minus 1 is 3 halves, or 1 1/2. So yes, that as well checks out. So both of these solutions work, x equals 3 or x equals 2. They're both true to this solution. All right, so this technique of multiplying by the lowest common denominator, if you pick the lowest common denominator right, you are going to get an equation with no fractions when you multiply it out, and that's the beauty of it. It becomes something that you've just had practice solving. All right, let's try a word problem. So Renee can mow the lawn in 20 minutes. Joanne can do the same job in 30 minutes. How long will it take them if they work together? Okay, so this is a distance, rate, time problem, but it's really a work rate time problem because we're not doing distance. So one thing I want to think about, I'll probably make a chart because we've gotten pretty used to that. I'm going to do rate times time equals work done. Okay, and I know that I've got Renee here, and I've got Joanne. All right. And I know that she can mow the lawn in 20 minutes, but it does not say she's working for 20 minutes. Joanne could do the job in 30 minutes, but that does not mean she's working for 30 minutes. How long would it take them if they work together? What that means is they're both working for the same amount of time. So I'm going to call the time x in this case. And the rate, I think, might be the tricky thing to figure out. If it takes Renee 20 minutes to mow a lawn, that means she can do 1/20th of the job per minute. So her rate is 1/20th of a job per minute, so 1/20th. Joanne can do 1/30th of the job per minute. Okay, and their work done, all you know is they're going to try to do the whole job. But rate times time, that would equal the work done as well. So 1/20th times x is just x over 20. And 1/30th times x is just x over 30. So I'm going to have x over 20 plus x over 30. I want that to equal one whole job that's being done. All right, so I'm going to solve this the same way that I just did. I'm going to get a common denominator, multiply it all out. So something that I know that 20 and 30 both go into is 60. So I'm going to pick 60, and I'm going to multiply the left side by 60 and the right side by 60. All right. So 60 times x over 20, the 60 and the 20, those cancel. 20 would divide into both, so we have 3x there. And then 60 times x over 30. 60 divided by 30 is 2, times x is just 2x. And 1 times 60 is just 60. So I've got 3x plus 2x equals 60. So I have 5x equals 60. I'm going to divide by 5, and I get x equals 12. X is my time that they both have to work, and I put it in minutes. So they're going to take 12 minutes to finish the entire job together, which makes sense because it should be less than either of them can do alone. But if it was less than 10 minutes, you'd be suspicious because that would be like 2 Renees and they aren't both that fast. If it was more than 15 minutes, you'd be suspicious because then they both have to be as slow as Joanne. So 12 minutes seems very reasonable in this problem. Okay, 2 more problems. So solve 4 over x squared equals 1 over x plus 8. This looks like a nice, lovely, simpler problem because it just says this fraction is equivalent to this fraction, which means I can solve it by cross multiplying. So I have 4 times the quantity x plus 8 equals x squared times 1, which is just obviously x squared. So I'm going to distribute 4x plus 32 equals x squared. Quadratic again, so I'm going to get one side to equal 0. Again, I like my x squared term to be positive. It's my personal preference. So I have x squared minus 4x minus 32 equals 0. And I'm going to look for factoring here. So it looks like I have x minus 8 times x plus 4 to equal 0, which means I think x might equal 8, or maybe x equals negative 4. And I want to try and see if I'm right. So let's plug in one at a time. Let's try 8 first. So I'm going to have 4 over 8 squared. I want to know if that really equals 1 over 8 plus 8. So that's 4 over 64. Does that really equal 1 over 16? Yes, if you divide them both by 4, it reduces and it works out. Okay, let's check the other one, negative 4. 4 over negative 4 squared. Does that really equal 1 over negative 4 plus 8? Well, that's 4/16. 1 over negative 4 plus 8 is 1/4, and 4/16 does reduce to 1/4. So again, that checked out. Both solutions work. We'd say they're both legitimate solutions here. All right, let's look at our last problem. Solve x plus 3 over x minus 1 equals 4 over x minus 1. Okay, now this has something that you could cross multiply. Honestly, definitely you're allowed. But I want, if you notice, these denominators are equivalent to each other. They match, they're the exact same thing. So that just means to be equivalent fractions, these numerators need to match. So I want just x plus 3 to equal 4. Okay, one way to do this, a simple method, I think. When I solve this, I subtract 3 from both sides, and I get x equals 1. Okay, so I think my answer is x equals 1. I want to check it out, so I'm going to try it here. So 1 plus 3 over 1 minus 1, I want to know if that equals 4 over 1 minus 1. So I've got 4 over 0, oh my goodness, equals 4 over 0. It looks kind of good, but it looks kind of bad because we've got a denominator of 0. We're not allowed to have that. So we say x equals 1 is not a solution, it does not check out. So this problem would actually have no solution. All right, hopefully you're getting a feel for this and how to make these problems much simpler than they initially look, and we'll practice more.